Good morning, everybody. Welcome to day 2 of the 2020 Coal Users Group Symposium. I want to introduce you to the group. I'm John Flannery. I'll be the moderator for the morning session. We've got 3 presentations, very good topics, I think. And I want to remind you that at the end of the 3rd presentation, we will have an open session to allow communication and interaction. And if there were any questions that came in late during any of the presentations, we'll try and pick those up at that time. Our first presentation today is by Ben Elliott with Luminant. Ben's going to talk today about a performance optimization center that Luminant began and is currently using. So Ben, welcome, and I'm going to turn it over to you.
All right, thank you very much, and good morning to everyone. Make sure. Yeah, I appreciate the time this morning with everyone and for the opportunity to share a little bit about our Power Optimization Center within Vistra and the services that we provide. To start out with, I thought I'd share a few facts about our company and hopefully eliminate any confusion. So Vistra is a fully integrated power company based in Texas with a generation side, and the company's called Luminant, as well as a retail side. We have over 5,400 employees. Our Luminant generation fleet includes over 50 power plants in 12 states across the country. We stretch from Maine to California, and we're responsible for almost 40,000 megawatts of power output. And this power output's from a diverse portfolio that we have of natural gas, nuclear, coal, and renewable energy. The retail side of our business includes 5 major brands. You may have heard of them: TXU Energy, Dynegy, Homefield Energy, Ambit, and U.S. Gas and Electric. And they stretch across 19 states, the District of Columbia, Canada, and Japan, and we serve nearly 5 million residential, commercial, and industrial retail customers. We're currently building the largest battery storage facility at our Moss Landing plant in California. It will have a 400 megawatt, 1,600 megawatt hour storage system capability and will be coming online late this year and into 2022. The Power Optimization Center, or the POC as we call it, is part of our Generation Services team. The Generation Services team provides engineering, technical, and outage management support for our generation fleet, and we also provide the 24/7 monitoring and diagnostics for all of our 50 facilities that we'll talk about today. The POC team consists of 16 team members. We have 8 engineers and 8 shift operations team members, and they're responsible for the 24/7 monitoring of over 190 turbines across our fleet. And then a little bit about myself. My name is Ben Elliott. I am currently the Senior Director of our Regional Generation Services team. We provide technical assistance and major outage planning and execution for our 5 operational regions across the fleet. I've been with the Vistra company, or with Vistra, since 2007. I spent a short time away in 2017 and returned in 2018. And prior to that, I spent 11 years with Georgia Pacific in the pulp and paper industry. All right, so a little bit about the POC. Let's talk about the Power Optimization Center. There we go. Little history about the POC. Luminant built the POC in 2005. And the original business case for the POC was based on improving heat rate at our Luminant coal plants in Texas by 2%, as well as 2 megawatts at our Comanche Peak nuclear power plant. The real-time operational benefits were quickly realized in the data that was being monitored by the POC. What started out as an 8x5 operation quickly became a 24/7, 365 endeavor. The Power Optimization Center, or again, the POC, is a premier monitoring and diagnostic center in the power industry. We've received much attention and recognition over the years. We've been recognized by INPO, the Institute of Nuclear Power Operations, and also the World Association of Nuclear Operators. Power Magazine hosted the first Connected Plant Conference in Dallas a few years back. The conference centered focus on the success of the POC, and during that conference, we were able to tour approximately 110 conference attendees through the POC here in Dallas. The POC is focused on providing M&D services that will help the plant to maximize efficiency, reliability, and power generation, and in turn, profit for the facilities. So the POC increases profit mainly in three ways: by partnering with all of our facilities across the country. The first way is through generation output or availability of the units. We help minimize equipment failures by reducing unplanned outages and derate events through our monitoring. That ultimately reduces the equipment forced outage rate, or the E4, of our units. The POC also reduces our operating costs at the plants. We work together with the plants to help decrease maintenance costs, O&M costs, through targeted maintenance spending and through decreased fuel costs by improving and sustaining the thermal efficiencies at our plants. POC also helps monitor environmental emissions. We help reduce emissions by reducing fuel usage, and we also continuously monitor environmental systems and controls at each of our plants. So a little more history about the company. In 2018, Luminant was basically a Texas-based utility, but in 2018, we merged with Dynegy, where we then expanded across the country. Pre-merger, the POC had access to over 750,000 data points through the PI historians. Since our merger in 2018, the total number of data points is now up around 2 million. On any given day, the POC receives about 1,000 alarms, which does sound like a bunch, but we actually want the alarms to come in. It lets us know that our models are functional and that the alarms are working and that we have them adjusted properly. The alarms are first reviewed by our POC operators, all of which are previous plant control room operators and shift supervisors. Any emergent issues are communicated immediately to the plant control rooms. And then any long-term reliability or thermal efficiency issues are reviewed and analyzed by our subject matter experts in the POC and in our generation services team. In all of the 1,000 alarms that we receive, it usually equates to about 30 to 40 what we call actionable intelligence items per day. And actionable intelligence basically means we have follow-up, something that we have to do, something that we have to check. So the POC doesn't just communicate alarms, we often take action in collaboration with the plants. POC has expertise in monitoring all of our critical systems associated with gas, coal, nuclear, and now our solar facilities. You can see on the PowerPoint slide here, it's mainly in three major categories: mechanical, electrical, and through our performance models. POC uses ideal model lists to build our models and alarms. And based on the instrumentation at each of our plants, models and alarms are built that help provide insight into the equipment health and performance. And in particular, the performance models look at performance and efficiency of the plant components or specific plant systems. And by monitoring the efficiency and the performance of these assets, more intelligent decisions can be made around capital. We essentially, like most all businesses, have a finite amount of capital resources, and so we want to make sure we're performing the right work on the right equipment at the right time. The next slide shows the POC's, what we call our layered approach for monitoring and for alarming. And basically, we use this layered approach to look at equipment from various perspectives. And we believe if you look at it from various perspectives, then the likelihood of an issue going unnoticed is minimized. We have as everyone knows, there are DCS alarms in the plant control rooms, but the DCS alarms don't always go far enough to prevent equipment failures. The DCS alarms alert the control room to a pending crisis with limited time to act. By utilizing the modeling, the rate of change of alarms, statistical alarms, and fixed alarms, the POC is able to better determine operational issues before they reach a crisis point. So communicating these issues to the plant control room, sometimes in less than 20 minutes from when the change is detected, it gives the plant additional response time to dispatch operators and take action, hopefully averting any type of crisis, equipment failure, derate, or plant trip. The next slide basically depicts what I just described more in a graphical form. If you look at the layered alarm approach that we use, the PF curve looks at equipment failure from the time of detection or the potential failure to when the actual failure or functional failure occurs. And by using our layered alarm approach, the time of detection is pushed back up the curve, which provides us early detection and maximizes our response time prior to failure. Another key aspect of the POC, we've developed a heat rate improvement program that's sustained heat rate improvements across our fleet for the past 15 years. By focusing on heat rate, awareness of the heat rate issues has actually permeated all levels of our organization, not just the plant sites, not just the POC, but throughout generation services. In setting up the program, a baseline assessment, we conduct a baseline assessment to establish where the unit is operating. And then we perform daily monitoring, cycle isolation monitoring, and in-depth reviews to point to issues that could impact heat rate. This information is used along with the plants to target O&M repairs and capital spend to help sustain heat rate improvements. The POC also partners with the plants to become basically an extension of the plant control room. We want to be more than just a second set of eyes or big brother watching the plants. So the day-to-day plant operations and maintenance needs around the plants, we help to minimize the time that the plant or to dive into issues that the plant may not have time during their day-to-day work activities. Again, the POC, we're a 24/7 operation, so we can provide additional monitoring, or more importantly, additional analysis of issues or data when the plants are going through the normal day-to-day business of operating and maintaining the plants. The POC also provides review of all plant coast downs and all plant startups. We've identified white turbine bearings on plant coast downs and provided the plant with timely information that's reduced outage durations. We review unit heat rate information within 24 hours of any unit startup. We've also helped minimize heat rate losses that occur with normal unit startups. So examples of like valves leaking by, stuck open, airbound feed water heaters, those sorts of things. The POC also manages what we call a fleet watch list, and we maintain a course of action procedure for each of the watch list items. The course of action is a procedure that states how we will respond to further degradation of the watch list assets. It's basically an agreement between the plant and the POC of what actions we'll take. With wireless capability in our plants, we're also able to deploy what we call crash carts, where we can add additional instrumentation to equipment and provide monitoring if there are specific equipment conditions or needs. We also provide automated notifications to plant management as well as to the support personnel throughout the company if there's any immediate notification of changes or actions needed associated with degraded equipment. All right, so the next couple of slides, I thought we would share with the group a few of our success stories that we've had across the years with the POC being in service. Hopefully you guys can see this. This first one, the first success story, actually occurred on April 5th of 2005, and that was actually the first day of POC operations. At that time, the POC was much like a plant startup, pretty chaotic, a lot of alarms, a whole lot of uncertainty. But we had an equipment reliability specialist that noted an increased vibration APR model alarm on a primary air fan. And the specialist called the plant control room. At the time, the plant control room, we were still relatively new, right? Day one. They really didn't know who we were and what we were all about, but they did send an operator out to check things out. The operator found that oil was leaking from the fan bearing and it was being drawn into the fan, creating an imbalance and causing increased vibration. The plant actually had a scheduled maintenance outage for the upcoming weekend, and they took that outage and made repairs to the fan at that time. And in our talks with the plant operations, it was agreed that if repairs hadn't been made, the fan would have likely tripped within a day or two after the startup of their maintenance outage. And the value that you see there is based on a 50% derate of the unit. However, I'll also share with you that the plant also let us know at that time that they had never in the history of the plant been able to survive basically an uncontrolled PA fan trip. Okay, the next example, this trend in the upper left-hand corner, hopefully everyone can see that. The trend is of unit load and main transformer winding temperature for one of our luminant gas plants. The unit had just returned from outage, and as the unit was ramping up in power, the POC received an indication of a high winding temperature on the transformer. POC contacted the plant control room, and we discussed the high winding temperature. And during our discussions, or at that time, the plant actually did not have a high winding temperature alarm on the transformer, but they did send an operator out to investigate. The operator found that all the cooling fans and the oil pumps were off. He found the local disconnect for the cooling fans and the oil pumps in the off position. It was actually left in the off position after work from the T&D group was completed during the outage. The operator returned the disconnect, obviously, to the on position. The cooling fans and the oil pumps were returned to service. And when he did rack everything back in conjunction with returning the power, the plant control room at that time did receive a high winding temperature alarm. The power for all the annunciators at that time was fed from the same source as the cooling fans and the oil pumps. So preventing this catastrophic failure of a transformer at the time was valued around $4.5 million. This specific unit that we have in the fleet has a low capacity factor. It doesn't run all that often. And it's likely that had we failed that transformer, the unit may have been retired. So this was a good catch. Okay, another example here for the POC and how we provide near real-time operational info for the plant control rooms. In this example, the POC received indication that condenser back pressure had increased on a unit. The increase had settled out just below the plant control room alarm set point. So the plant did not have an alarm. We had some statistical models and some other rate of change alarms that were set just below the settings in the plant control rooms. The POC contacted the plant control room, and the plant did investigate. They did find that a valve had failed open due to a failed controller card, and that card was replaced with the unit online, and the condenser back pressure was restored. All right, and then our last example, again, is around some of the heat rate sustainment or improvement that we do through our cycle isolation valve leakage monitoring. We actually work with the plants, usually prior to their major outages, to provide insight on any heat rate activities or components in the system that are actually penalizing the units from a heat rate standpoint. Cycle isolation valves are typically on that list, and we normally provide a prioritized list of valves in need of repair or replacement that the plants can use in their planning for their major outages. And the graph in the upper left basically shows you heat rate performance prior to the outage, and then the way heat rate performance coming up out of the outage. In this case, we were able to identify repairs to actually several cycle isolation valves, and the repairs were completed, and the resulting improvement in heat rate was around 350 BTU per kWh. Okay, so those are just a few examples of some of the good catches we've had. Now I wanted to share with you a bit of information around our M&D service, or some of our future opportunities that we've had here recently. The first is we did acquire a 2-on-1 combined cycle facility earlier this year, Sayreville, right outside of the New Jersey area. And we've built all of our advanced monitoring, APR monitoring, and implemented all of our statistical analysis components for this plant facility. We've also this year, actually at the end of last year, developed APR modeling for our Upton 2 solar facility in Texas. It's a 180 megawatt solar facility, and we're now monitoring and providing diagnostics for that solar plant site. And we've also recently partnered with USA Nuclear Alliance, along with the DOE, to deliver M&D services to 2 nuclear facilities outside of our fleet. And we will begin offering the M&D services in 2021 for those facilities. And then lastly, we've recently partnered with the McKinsey team in advanced analytics and machine learning. So we are currently embarking on a partnership to utilize advanced analytics and machine learning algorithms to help us further improve on our heat rate sustainability and performance, as well as helping us with prediction of equipment failure or changes to operational status. All right. Okay, and then lastly, we talked a lot about the POC, the services we provide. Obviously, it's all because of the technology that we have built, which is certainly the cornerstone of the Power Optimization Center. But we wouldn't be successful if it wasn't for the people and for the relationships that we have with the plants. So as I mentioned, the POC is staffed by experienced plant operators and engineers, and they actually seek to build lasting relationships with the plant personnel. Again, we don't want to be considered big brother or the corporate eyes that are watching plants. We want to partner with the plants. If they're having issues, problems with equipment, and they don't have the time to watch it like a hawk or to continue to monitor it 24/7, we do. We have the resources, we have the people, and quite frankly, that's what we're here to do. So we want to partner and build those relationships with our plants. And that was so important with the merger with Dynegy. I mean, again, we went from a Texas-based utility to over 50 plant sites across the country. And here we are with the POC trying to learn new plants, new control rooms, new people, and build relationships, and to help stand up the monitoring and diagnostic capabilities. What's unique about us is we are a service group. We're here to hopefully drive value in the plants. We don't sell parts, pieces, or software. That's not what we do. What we do is help the plants achieve their safety, their environmental, and their operational goals. We monitor gas, coal, nuclear, solar, and now batteries. And we've also developed models for wind and hydro. We're also what we call a living, continuously improving organization that grows through our own experiences. I shared with you several success stories, but we've also had several misses during our time in the POC. But by leveraging our 15 years of monitoring and diagnostics experience, plants are able to use us and hopefully see immediate benefit. Whereas in comparison, if you were to build out an M&D center from scratch, that would typically take about 3 to 5 years to show a positive return on the investment. Here at the POC, we also use a root cause process to investigate all of our in-scope equipment failures. Excuse me. The events are reviewed from a monitoring and diagnostics perspective. The alarm and modeling are reviewed for improvements. And if the plant needs additional instrumentation, we'll recommend that. And then all of the lessons learned are applied fleet-wide so that all plants can benefit where it's applicable. I know that was a lot of information. I have no idea if you guys could hear or understand me. Hopefully you did. Again, I do appreciate your time and for the opportunity to share uh, the benefits of the power optimization here within Vistra, within Luminant. And with this, I'll conclude my presentation and turn it back over to the team. Thank you.
Thank you, Ben. That was a very, very good presentation. Lots of interesting information. We're waiting for questions to come in. One is up, and they're asking, you've mentioned a couple of times not wanting to appear as a big brother looking over their shoulder. So how have you, what did it take and how have you developed that interface?
Yeah, that's actually an excellent question. As you might imagine, I'll go back to the merger. You know, obviously, if you've spent time in plants, or anyone that's spent time in plants, you know, and you have an outside entity that is watching your units or watching the performance of your site, you can be skeptical of what's going on. You know, everything from folks' capabilities to pride to all these things of if someone else catches something that I don't. So we do spend a lot of time with plant control room operators. We try to build that relationship with the control room operators. We've done things, you know, prior to the COVID outbreak, obviously, but we have initiatives where control room operators from the plants will come visit the POC in Dallas, where they'll spend a day in the life with our team. We'll show them a little bit about what we do and how we do it. And then our operators will also visit plants in the control rooms and spend time on shift. Again, the sole purpose is twofold. It's to build relationships, and it's also to share with the plants the capabilities of the POC. And the other piece of this question that I'll share with you is the plants can reach out to us at any time. If they do have an issue, they can call the POC directly, and they can state what the problem is, what they're asking for, and we basically create a ticket that tracks the action item or the actions that we'll take, and we make sure that we communicate that to plant leadership. So bottom line is it comes down to relationships, and we work very hard at trying to build those relationships across all plants.
Very good. One more quick question, Ben. Based on the incidents you have intervened in, does the center consider that you've recouped the cost of the facility and it's justified?
Yeah, another great question. You know, most utilities, that's the single largest question of whether or not to build out M&D services. For us here at Vistra, we do believe the payback is there. We do believe the return on investment is there. It comes through a variety of ways. I shared a couple of the success stories, but as you might imagine, a fleet of this size, even small incremental improvements around heat rate, just fuel usage alone, can more than pay for the POC. But we've also caught, you know, bearing vibrations and temperatures, you know, bearing failures. We've caught issues on plants during the critical time of the year, which for us, especially in the state of Texas, is the summer. So we've identified issues in the summer run that could or would have tripped units offline during the peak periods of the day. And so based on those events, we do believe that the POC is paid for, bought and paid for.
Very good. Ben, thank you very much. Very good information, a very good presentation.
Okay, thank you.
Switch to our second presentation of the morning now. And just want to remind everybody to stick around at the end of the last presentation because we will do an open Q&A, and there is an open Q&A tomorrow morning as well. Our second presentation this morning is by Artis Johnson. He's a senior risk engineer at Energy, and Artis is going to tell us about a filter fire that occurred at his plant, what their analysis of the problem turned up, and what the rest of us can take away from it. So Artis, welcome, and I'm going to hand it off to you.
All right. Thank you, John. There we go. I think that will do it. That should have my presentation there visible. Appreciate it. This is a little bit of a different presentation for the coal users group, but what I want to primarily focus on is some decisions that were made associated with an incident. As John said, I'm a risk engineer for Entergy. I've been with Entergy for a little over 40 years and primarily deal with loss control. And the incident that happened here was one of our combined cycle plants, and it occurred during construction. And so I want to basically highlight some of the decisions that took place that led up to the incident, some decisions that took place actually during the incident, and some more that took place afterwards, and hopefully, get people to thinking a little bit differently about how things, about their decisions and potential consequences. So this particular power plant was under construction, and it specifically had to do with the inlet filter portion of the plant. The filter media had been delivered to the site, and as you can imagine, during constructions, especially one that has a timeline that they're trying to hold to, lay down and that sort of stuff is at a premium. So this filter media is basically a honeycomb cardboard type construction that's treated, and then the leading edge has a coating on it that protects it from flying debris, etc., on the leading edge to prevent deforming and wearing away during the cycle. So the medium, as you can imagine, took up a lot of space in the warehouse. It had to be covered and protected from the weather, and warehouse space was at a premium. So at the time of this decision, the inlet filter structure was more than 90% complete. Somebody came up with the idea, you know what, we could start putting this filter media in the filter house itself and get rid, open up a lot of space in the warehouse. And so the decision was made to go ahead and do that. And at the time of this incident, the filter media was almost completely installed inside the filter house. So there's a quick shot of the front side of the filter house there. So at the time of the event, we'll start off with a little chronology here. At 11:21, a call went out over the radio, smoke coming from the filter house, and the call was placed immediately to call the fire department. And so multiple personnel got involved with attempting to extinguish the fire with extinguishers. A hose from a water truck was run over there. They actually formed somewhat of a bucket brigade and grabbed anything that was handy that would hold water. And I from what I understand, there was guys using hard hats, lunch boxes, anything they could. And I kind of want to highlight the mentality of what was going on here, in that this was under construction and everybody on that site was focused on getting this plant built. That was their whole goal. So right after this report went out, management was informed of the fire on the site. And at 11:26, it was determined that the efforts to contain the fire were not effective, and they made confirmation that the fire department was contacted and they were en route. Before the fire department arrived, at 11:31, the sheriff's department arrived. And that sheriff looked at things that were going on, looked at the personnel that were involved, and ordered all the personnel to be evacuated from the filter structure and the plant areas for accountability. So based on what I said earlier, this site was all focused on completion of this project, and getting this fire, or the fire occurring, was going, everybody knew was going to interfere with that completion. But it took this sheriff that didn't have all those preconceived goals, etc., to understand that, hey, we're in a position now where losing somebody's life or getting somebody injured is a higher priority than getting this fire out. So that was a good decision based on that sheriff's new perspective on that. So basically, what I want to highlight there is, when you're in a process, when you've got a goal, don't hesitate to bring in people occasionally during that process, whatever that goal is, that don't have all those preconceived ways of thinking, and can see different aspects that you may have missed or have overlooked intentionally. So site personnel then, at his request, were requested to report to the lunch tent. One individual was identified at that time that was exhausted, needed assistance off of the structure. The temperatures during this particular time were still elevated. So even though this was at night, it was determined that what happened there. Okay, there we go. 11:35, the fire department arrives on scene. Officers escorted up the filter structure to assess the fire. 5 site personnel remained to assist in hose deployment. They knew they were going to have to deploy these hoses up several stairwells adjacent to the side of the filter house. And the incident commander requested that the information on the filter composition, the number of personnel that were on site, and make sure they were all accounted for, and the names of the individuals, the 5 individuals that stayed behind to assist the fire department with the hose deployment. And that information, the personnel on site, the accountability, all of that was actually delivered to him in less than 5 minutes. Once again, another decision early on in the construction process was to get to make sure this site, all these construction hands, were ready if something did happen. And so they conducted active fire drills with all these folks in place, and because of that, it paid dividends. In less than 5 minutes, they had everybody accounted for. Everybody knew where everybody was, and everybody was okay, other than the individual that was exhausted. So there's a shot of the actual incident. As you can see, it's rolling quite well. So at 11:40, the second first aid is become aware of. Individual reported that they couldn't catch their breath. At this point, EMS was on site and actually took over the care for that particular person, and they determined it was hyperventilation and exposure to the fire extinguisher powder. And 11:50, 10 minutes later, continued search for what exactly the filter was made of. And then at 12:01, incident command requests power to be shut off to the transformers to allow for strategic positioning of the apparatus for water attack over those power lines and transformers. And the power company dispatched reported that the transformers were de-energized at 12:30, and by then the fire department had the apparatus in place, and the attack was mounted with the nozzles mounted on the trucks. And at 3:35, the fire department was declared the fire out and the scene secure, and left the scene. So just a few pictures of the end result there. As you can see, the fire tended to be over towards the right-hand side. You can see the stairwell there on the side there that the fire department had to use and the employees had to use to access the area. Classic burn pattern starting over here, showing that the source of the fire was right around these doors somewhere. Starting off at the lower elevations, you can see hardly any damage to the aluminized structure there. A little shot of the media on the lower elevations. It kind of gives you an idea of what we're actually looking at. And that fueled the fire. And then as we move up in elevation, you can see how the aluminum structure began to melt because of the heat. And a little bit higher, you can see it actually became molten and was flowing out of one of the drains there. That's one of the racks that the filter media sat in, and a couple of doors that you could see where they were open during the fire attack, and the heat was coming out of the building. This particular shot was one of the things that helped us realize how hot it got. If you notice, the key there is actually this portion of it is melted away. So that gave us an indication of just how hot it got up there. This is on the opposite side from the stairwell. Once again, gives you a good idea that the source of that fire was right below this area. And going back, the next picture was actually taken just to the right of where that connection is on the inside. You can see that the airflow due to the chimney effect was pulling the heat away from all of this, because that would have melted very easily. So fire marshal's report, the investigation wasn't conclusive. They never could determine exactly what caused this fire. They did say that the most likely scenario was exterior welding along the southeast corner of the filter house that led to sparks from the welding being drafted into the interior. There were a couple of hatches that were open over in that direction, and thus igniting the filter media. Other potential causes, and this was addressed. Smoking was allowed anywhere on the site, and evidence of smoking was found in and around the filter house. So the actions that were taken after, so post-accident decisions, hot work procedures were changed and required a fire watch on both sides of any metal barrier where hot work near a metal surface was taking place. So, and storage of filter media, they actually took all the filter media out of the filter house and didn't reinstall it until all of the work was on that filter structure was complete and ready for testing and commissioning. And then last of all, smoking was banned from the entire construction site. And that was not a popular decision, but afterwards, there wasn't a lot of resistance. So one thing I want to emphasize is make the hard decisions early. The decision to do the fire drills at the construction site was costly. I mean, these guys ought to be working. We've got deadlines to make. But if they're taken seriously, fire drills are effective and have a significant impact on personnel safety and the effectiveness of the response. So site accountability, as we said earlier, accounted for hundreds of workers, and it was provided in less than 5 minutes due to drills that previously had been conducted. Everybody knew what to do, where to go, and they did it. And fire prevention is only as good as the attitude and culture of the people that put it into practice. As we said, smoking was banned from the entire site after the fire. If it was a good decision after the fire, it would have been a better decision before the fire. Wouldn't have been a popular one, which is probably why it wasn't made before that. And then make the hard decisions early. No procedure can ever replace a cautious contemplation and understanding of a given situation. So apply situational awareness to any of your decisions. And by that, I mean, ask yourself, ask the group, ask the project, what's the worst thing that can happen if we do this? In this particular case, warehouse space during the construction site was at a premium. There's never enough, but storing combustibles material in an area of ongoing hot work was a recipe for disaster. And that's, I guess, kind of short, but sweet. And hopefully I have given you some tools to consider what may be going on around your particular area, and some food for thought. Any questions?
Thank you, Artis. We're waiting for questions to come in. I've got one quick one for you. So as a result of the fire and the damage that was committed, how did that affect the project schedule?
It turns out we actually were in a really good shape to recover very quickly. This was actually the first of 3 combined cycle units that were being built at different geographical locations, but all on exactly the same plan. And so basically what happened is the second one was under construction, and was actually we actually took the filter house from that site and brought it over to the first site. The third site sent theirs to the second site, and there was time to get the rebuild, if you will, the filter house for the third one, and not interfere significantly with any of the deadlines.
Excellent. And it sounded like there may have been 2 visits with the EMTs at site, but no serious injuries.
That's correct. Everybody recovered nicely, and no lasting effects.
That's great. Well, we're going to wrap this session then. Thank you, Artis. That was very interesting. And please stick around, because we'll have an open session at the end of the next presentation, which we're going to step into now.
Certainly.
Bob or Louise, our next presentation is going to be provided by Evergy, which used to be Kansas City Power and Light, and Black & Veatch. We have Adam Farrell, who's a structural engineer with Evergy, Mike Kralik, who's a principal engineer with Evergy, and Mark Dittus, who's a project manager with Black & Veatch. They're going to talk to us about coal silo monitoring. Many of us are aware of the incidents that have happened over the past few years where corrosion has led to failures in coal silos. Adam's going to lead off on the presentation, so I'm going to hand it off to Adam, and let's learn about coal silo monitoring.
Okay, thanks, John. Can you hear me?
Yes.
Yes, we can.
Okay, great. So as John said, our presentation is titled Coal Silo Cone Shell Weld Monitoring. We took kind of a different, maybe outside the box approach. So we're going to present a project that was implemented at an Evergy facility that consisted of applying strain gauges to a coal silo cone with the ultimate goal of monitoring the silo cone to prevent collapse. As John said, this project was a collaboration between Evergy and Black & Veatch. Again, my name is Adam Farrell. I am a civil structural engineering manager with Evergy. Also presenting with me today are Michael Kralik and Mark Dittis. Michael is a structural engineer with Evergy, and the concept for this project was really his idea. Michael also managed the project on the Evergy side. Mark is a project manager with Black & Veatch. Mark managed the Black & Veatch team that assisted Evergy with structural modeling of the silo cone and strain gauge selection. Next slide, thank you. So this slide shows little information about Evergy. So Evergy is the company that was formed from the recent merger of Kansas City Power and Light and Westar Energy. We serve customers in western Missouri and eastern Kansas with a diverse fleet of power plants, including coal, natural gas, nuclear, wind, and solar. This slide shows some information about Black & Veatch. Black & Veatch is a multidiscipline engineering firm headquartered in the Kansas City area with offices throughout the world. They serve a number of business lines, including power, oil and gas, telecommunications, and water. So this slide really shows the concern this project was attempting to address. So the figure on the right shows a section view of a typical silo shell and cone interface. And the blow-up view shows the complete joint penetration weld connecting the cone to the silo shell. Unfortunately, this weld, as you know, has failed in multiple silos at various plants throughout our industry for a number of reasons, some of which included corrosion, lack of fusion, improper weld metal, to name a few. So stemming from this industry concern, Michael and I were tasked by Evergy executives to inspect this weld for all silos in the fleet. When we started thinking about how to inspect the weld, we encountered many issues that added complexity, including interior silo linings and access concerns. So many of our silos have a gunite interior lining, and we didn't want to create a potential weakness in the structural system in order to access and inspect the weld. So Michael had the idea of applying strain gauges to the silo cone, and by monitoring the strain measured by the gauges during filling and emptying of the silo, we could determine if areas of the weld were not loaded. And we were able also to capitalize the cost of this new installation with the hope of avoiding repetitive inspection O&M costs later on. So now I'll turn it over to Mark to discuss the structural modeling.
Okay, thanks. So in order to determine if the strain gauges could provide any useful information, that would allow for a means of identifying where a crack was, Black & Veatch built this FEA model, as shown here. The model started at the weld line. It included the skirt and all the supports. It did not include the silo itself. The model was built with our JT Strudel modeling software. This is something that our modelers like to use this for complex systems because of the capabilities and tools that it brings to the table. So, as I mentioned, since our main focus was on the weld, we did not include any of the silo above the cone. And as you can see, the model was set up with the more refined mesh at the top, where we were most interested in seeing the ability of the strain gauges and if they could provide any readings. At the top portion of the silo, we had elements at each degree, so 360 of them total. And the height of each element was then set up to be approximately the same width. So they represent about a 3 inch by 3 inch area. And then the lower we went in the cone, the less refined the mesh became. In the model, we imposed both the vertical and the tangential loading to try and represent the weight expected when the silo was loaded with coal. And the supports themselves, these were modeled as springs based on the size of the beams. So different size beams would have slightly different spring ratings. Okay, next. After developing the model, we had to run a baseline case, and that's what you're seeing here. And the baseline looked at what would be expected if the silo was fully loaded and the weld was, completely intact. So we looked at different elevations, and what's shown on this graph is really representative of what the readings looked like at all elevations. As you can see, there are locations that had lower strain readings than others, and these correspond to all of the support beams. So in general, we thought this pattern developed matches well with what we would expect to be happening within the silo, within the cone. So next we started to simulate cracks. We did this by forcing certain elements to a zero strain condition. Our goal was to see how small could a crack be and still be noticeable. As a reference, the model indicated that a crack would need to be pretty large before the silo would actually fail, or the cone would actually fail. And so what you see here are a couple examples of the modeling results. We started at 16-degree crack and worked our way down. Shown here is an 8-degree, or about a 23-inch long crack. It shows a very apparent change in the normal pattern, but that's still pretty large, so we kept going smaller and smaller. The second graph shows a 6-degree or 15-inch crack. Again, this is still really apparent. You can see a change in the expected pattern. We actually worked down to about a 1-degree crack and found that the pattern change can be seen even at this small of a crack. However, it's not as readily apparent. To really see it at that point, some form of data analytics program would be needed to notice it. So since we wanted to test this system first, we wanted to try and set this up without using a monitoring program. So the spacing we were going to use was going to be based on something that was a little easier, more visible change in the pattern. After looking at the length of the crack, we also looked at the location of it, and I think you got ahead of me there, Michael, sorry. We also looked at what would happen at a support location versus a non-support location, and here you can see there are some slight differences, but it's still readily apparent. Even if it's at a support, you can see a change in the pattern. So we felt pretty comfortable that this idea was going to work, and we could install the gauges and try and find the crack. All right, next one. So our intention was to put the gauges as close to the weld line as we could. With the skirt, this was expected to be maybe 1 foot 9 inches below the cone weld joint. And Michael will get into more details on where we ended up putting these and how we got to that location. We decided we were going to, since it's an initial trial, we wanted to be very conservative in the number of gauges. Looking at the graphs, we knew we could get away with 6 degrees of spacing and still see something. However, we decided to go with more, so we went with 128 gauges. That spaced things out then at about 3 degrees around the silo. This gave us a lot more information. We were able to then confirm that we were able to see a change in a pattern. So at this point, we solicited proposals, and Evergy purchased some equipment then from ITD. Michael will walk us through then the process.
Scaffold was still required, and we had the benefit of having stainless steel cone that also had lead-based paint on it. So after we built the scaffold, we had to perform lead-based paint abatement, and then we began laying out the strain gauge locations. The girders and beams supporting the silos were used to support cable tray. So the electrical contractor laid out the approximate locations of the strain gauges, installed the cable tray, and then it was determined that one of the tray locations was a little bit of a hindrance. But we were doing all this in preparation for ITM, integrated test and measurement, to perform the equipment installation and the strain gauge installation. So After the abatement, we started, I should note, the finite element model, we tried to get the strain gauge installed as high as possible, as close to that weld location. Really, what was the limiting factor was how high the abatement could take place, and the strain gauge installation. They were impeded by the skirt and the skirt plate that surround the cone of the base of the silo. We did the numbering, as Mark mentioned, 1 to 128. We started at azimuth 0 degrees, which was plant north on the silo, and installed the gauges clockwise around the cone. This is what it looks like when the locations get the surface prepped, ground down to get a nice flat metal surface. And then this is on the outside, right above the cone, right at the interface of the cone and the shell, where the data acquisition controller was installed. We ran an Ethernet cable from this panel to the Pi server in the DCS room, and we powered it with 110 volt feed. As work progressed, cables were landed. Each cable had a unique identifier with just a tag number and a number, and run in quadrants. The cables were run in quadrants to try to minimize the cable lengths. They were laid in the trays for the gauge installer to land the cables, connecting to the gauges, and then land them in the chassis of the controller. And here's a photograph. You can see the skirt and the base plate of the skirt and how that kind of limited the access, but this is the installation of the gauges in progress. Where a gauge fell on a vertical butt weld joint in the cone, we offset it slightly, and we think later on we'll talk about that may have had some impacts on some of the data. I'm going to try and play this. We did issue a hot work permit. This is a video of gauge installation. It's just a series of small welds, and as you can see, very little concern with hot work, very small sparks, very tedious, time-consuming work. But the company worked very efficiently and did a pretty good layout. So this is the completed. All the cables are landed, and now we're getting ready to start verifying communication with the Pi server. I threw the logo of ITM in there. They provided the data acquisition system and the gauges, so we kind of relied on their expertise as with regards to types of gauges and the system. Then, since we were in outage, we thought, well, why don't we test it, make sure these gauges are actually doing something. So we initially wanted to remove the knife gate at the base of the silo, at the base of the cone, and install a blank. We should have done that. We didn't. So we tried plugging the knife gate with different materials and filling with water, and we had a little bit of an incident, but nothing major. But we were able to get some data, and so this is just from the initial installation. The strain gauges, as you can see, are highly sensitive. The blue line indicates basically the zero condition, and we believe that a lot of that is what's being reflected is probably just it's reading some thermal differences due to ambient temperatures. The orange line is values that were read during the filling process with the water, and the peaks in the upper left quadrant correspond to the location where the impact was happening from the fire hoses that were dropping the water into the cone. And then this is we've now, as many of you know, we've had challenges in 2020 of all sorts. And our industry has felt the impact of numerous challenges. We've collected data, but it's been sporadic. The unit had a little bit of trouble coming out of outage. And so we've been kind of up and down. We haven't had a good long opportunity to collect data, but some of the data that we have collected and we've started analyzing, we're starting to see some trends forming, and we're getting some good data. We just haven't gotten into the meat of it. This, like Adam explained, this is kind of a phase 1 trial installation. As Mark noted, we put far more gauges on probably than were necessary, but we are still, as far as the conclusions go, we're still evaluating data. We have high hopes for the system, and with financial approvals, we plan to implement phase 2, which would be installed on all of our silos fleet-wide. And that's all for our presentation.
Thank you, Michael, Adam, and Mark. While we're waiting for other questions to come in. So Mike, you go ahead with phase 2. Will you use the same number of strain gauges on each of the other silos, or are you going to do some more testing before you finalize that?
That's a very good question, John. We haven't gotten into too much detail. We haven't really actually started the process of implementing phase 2. Right now, we're mainly in the kind of the budgeting phase and the the 5-year budget. So we've spent most of our effort on trying to analyze the data that we have received and then figure out what the budget is. Obviously, the number of gauges has an impact to that budget. So to answer your question, I'd say the one thing that might change is these are uniaxial strain gauges, so we're only reading in the vertical direction. There's kind of been some discussion with some of our consultants on whether biaxial gauges might be appropriate. If we were to do that, we'd have to look at the chassis and the number of points that would need to be landed. And so in that instance, maybe we'd go to half the number of gauges if it greatly expanded the number of chassis. So, and that's getting really quickly into a realm that I'm not an expert in. So, but I'd say the number of gauges would probably be pretty consistent where we're at. We may consider different type.
Okay, thank you. Let's see, do you have a question? Did you have any concerns about introducing a new type of failure site with the installation of the installation sites, even though they're so small?
So if I understand the question correctly, maybe the welding process would be cause for concern. So the silo was unloaded, it was in outage, so it was empty. So there was the only strain, the only stress on the cone was its own weight itself. And it was as you could tell from the video, I mean, it's very small resistance weld. We actually even considered just adhesive. We picked the weldable type because they're a little more durable. And our consultant kind of had a hand in that. But I think to answer the question, no, we don't feel that we've created any sort of notch or weak point where we've installed the gauges. I should add one item too. We did have strain relief tabs welded on directly below the strain gauge so that it wouldn't, if something happened, the wires wouldn't get pulled off, the gauge wouldn't get pulled off. But no,
Okay.
To answer your question, no, we're not concerned.
Okay. Mark or Adam, so you tested it initially with water in the silo, and I guess some of the other plots were probably from refilling the silos with coal. Have those all consistently same relationship to one another? The amount and type of stress all the way around the silo?
Oh, I can answer that. That's one of the items we're still evaluating. There are some readings that are not consistent, so we're trying to understand. And Michael mentioned about the vertical weld seams. There seems to be some differences as you get closer to those vertical weld seams compared to what you might expect or what the other readings are. So in general, whether it was water or coal, the readings were fairly similar. But if you look at the readings around the silo or the coal, the cone itself, there's some items that still need to be determined to understand exactly what we're seeing there.
Okay. One other question I've got. Could you share any information on cost for the system? Or is that considered proprietary?
We can share a little bit. So it was a fairly significant capital cost. I think it was in the order of between $150,000 to $200,000 for installation. We had also bid out some of the inspections and the cost that would be, and just with the access and having to remove the gunite liner and certain things and in the silo at the cone near the weld to actually do the inspection of the weld, which was probably in the range of maybe $40,000 each inspection. So, we felt that this was worth at least exploring and trying a capital option, and even if we could identify only certain areas in the silo or in the cone that we would have to inspect, or go in and see what was really going on with the weld, we felt that really offset the cost. And we also had additional cost in this first installation. Just, we had sized some of the data acquisition and the chassis and things for all of the additional silos at the site. So there was some additional costs that probably could be attributed to other silos at the site. So, based on kind of all those things, and we were also concerned with, how many times and how often would we need to inspect these. We felt that the offsetting cost was very equal, and obviously capital dollars are better spent, at least for us.
Sure. Adam said that I'm assuming the gunite was removed so you can inspect from the inside because of access on the outside. What type of NDE did you do to the existing weld? Or what NDE processes did you use to evaluate the welds, the weld joint?
Well, we actually haven't done any destructive testing there. We haven't done any NDE of the weld. Michael helped me out. I think we were going to use RT. Was that what?
Yeah,
we were going to do?
We were going to do phased array UT. And again, what we were concerned about was, as we've heard, all of us that were at Electric Power and in Nashville a couple of years ago, and we heard about doing destructive testing, and it proved very, very valuable for TVA because they found some things. Our executives, made the decision that the cost at the time We were at end of outage, end of year when we came up with the destructive examination plan. The goal for this project and this approach is that if we see areas of anomalies, then we can target our repairs. We can pick a quadrant, we can go in there, we can isolate and remove, and we can grind out the weld and replace it in a targeted fashion rather than the entire silo for all 7 silos. And yes, we would probably, if the opportunity presented, the strain gauge data indicated a possible anomaly, we would probably do the approach, but more on a more limited scale. Go in, remove the gunite, do phase array UT, partial destructive, maybe PT, but targeted repairs is the goal.
Yep, very good. Well, I'd like to thank Adam and Mark and Michael for their presentation this morning. I think that's very good follow-up on what the group has heard before in Nashville, in Vegas, on the failures that have occurred in the coal silos. At this point, I want to thank everybody for participating this morning. I think we had 3 very good presentations. Ben talked about the Performance Monitoring Center at Vistra. Artis talked about the fire that occurred in the inlet filter building at Energy. And we've had Adam and Michael and Mark tell us what they've done looking forward to try and evaluate the coal silo concerns that we've experienced in the industry. The plan is to have kind of an open floor for questions at this point in time. So if there's anybody out there with questions about any of these presentations, we'd certainly love to entertain them now. So, or maybe if Ben or Artis or Adam or Michael or Mark have questions about the presentations we've had this morning, we'd love to see them.
Can y'all hear me?
Yes. Go ahead.
I did see a couple questions come in around whether or not the POC team builds their own monitoring or diagnostics. And the answer is yes, we do use outside software systems, created by other companies, statistical software systems, other advanced pattern recognition type software. But our team is trained on how to use those systems, which includes being able to build APR models, train the models, and basically do the maintenance on the models to make sure that they're accurate. So our team does have that capability. I think I also saw a question around if we provide services outside of Vistra. The answer to that is no, not typically. But as I mentioned at the end of the presentation, we have just recently partnered with USA and the Department of Energy, and we will be providing commercial monitoring and diagnostic services to 2 nuclear power plants outside of the company. And we have provided services. We provided services to We Energies several years ago as well in a commercial service agreement. So I did see those 2 questions on the side here, so I thought I'd answer those.
Ben, another question's come in and says, does the POC provide severe weather monitoring to help minimize plant disturbances?
I chuckle. I'm trying to make sure that's not one of my team members. The short answer is yes. And when we were a Texas-based company, that had 20-some plant sites, it was no big deal. But now that we're stretched all over the country, 50-plus sites, our inclement weather notifications has proven to be quite a task for us. So we're looking for ways to continue further automating that and using technology to help us. But the short answer is yes, we do provide inclement weather updates and alerts to our plants.
Any questions for our friends from Evergy and Mark at B&V about the coal silo monitoring plan that they've developed? Doesn't look like we have any more at this time. Bob, are we going to run the combustible dust presentation?
Let's go ahead and move to closing, John. We're going to do that video this afternoon.
Okay. I want to again thank everybody that provided presentations this morning. Thank you for putting in the time and effort. And if anybody has questions in the background and would like to submit them, we will have an open session tomorrow morning, Thursday, where the floor will be open and questions can be presented on any of the topics that are presented during the Coal Users Group Symposium. I want to say thank you for joining us, and it's been a privilege on my end. So we will see you when the sessions start this afternoon. Thank you.
A great way to stay in touch with your peers throughout the year, once a member of the Coal Users Group and sign into the website, is go to Forums. And in the Forums section, you can select My Subscriptions and Settings and identify those forums that you would like to receive notices on when someone posts something. Great way to stay in touch with your peers throughout the year. That's simple.